Hello, geometry. Are you ready for the shortest video of all time, hopefully? Let's jump right into it. We're looking at the second half of 7.5, all right? And we're looking at some properties of chords. What is a chord? A chord is something that it's a segment that goes from edge to edge, right? That is a chord. It went from edge to edge, okay? So it's not a line, it's not infinite, it has a clear beginning and end, okay? So we're going to draw a chord and label it AB. So here's a point and here's a point. Boom, I have drawn a chord. We're then perpendicular means a right angle and bisector means to split in half. So we're going to draw a segment that is both perpendicular to AB and also a bisector. So what that would look like is something like this. Right? This is a right angle here, and then this half is the same as this half. And we're going to call this point M for midpoint, okay? And then we'll call this point right here N, as it says here and here. So the perpendicular bisector is a radius of the circle. This is a radius. You know what, let me not go all the way through. Let me draw it like this. Now it's a radius, okay? So that is a radius because it went from the center to the edge of the circle. Okay? AM is congruent to MB because we said that it was being split in half. So this half is the same as that half, which is what that's saying. And then an interesting fact that occurs is that this half of the arc and this half of the arc are the same. It's kind of a fun thing, I say in quotes. It's an interesting thing that happens, right? Not only are we splitting the chord in half, but it also splits the arc in half, okay? And then angle AMN is equal to 90 degrees, of course, right? These are two 90-degree angles. So let's mark another point on the circle and label it D. Let's mark another point and label it D. And then let's say, I forget all of my directions here. Let's mark another point on the circle and label it D. Then draw the radius O to D. O to D. Measure the distance from OM and copy it onto OD and label that intersection E. So I can't actually measure here, but we're taking this distance from O to M and we're going to do the same thing. Should be able to we're going to take this guy and we're going to do the exact same distance. You see what I'm saying here? If I take this and make it the exact same, right? You see what I'm getting at? So boom, there's E. So from O to M and from O to E is the exact same distance. I hope that makes sense. Make a segment 90 degrees from E and construct a second chord, FG. So 90 degrees that goes through E. That is not 90 degrees. I want something like that. That'll do, right? And that's FG. I said this was going to be the quickest video of all time, but I'm struggling to draw. I'm sorry. So make a segment 90. Compare the lengths of A, B, and FG. Guess what? They're the same. guess what? They're the same. These two distances are the same, and these two are the same. And these two arcs are the same as these two arcs at the top. So no matter what you draw, we're basically creating a replica, right? We're creating a replica. Anytime you have a 90-degree angle with a chord, you're basically creating a replica. Does that? I hope that's what we're trying to reinforce here. Because OM and OE are congruent, we can say that two congruent chords are blank from the center of the circle. They are equidistant. All right. So I don't. That drawing was a little clunky. I'm sorry, that took me some time. But let me just say in like a 20-second nutshell, when you have two chords that are the same distance from the center, right? OM and OE are the same. When you have two chords that are the same distance from the center, well, their lengths are the same. AB and FG are the same. Right? That's when the chords are equidistant from the center, their lengths are the same. That's what I want you to take home from that. Okay? And we're just going to use that to help us out here. So EO and OF are perpendicular bisectors. So right angle, AB is 16, OF is 5, and GD is 48. We're just using those properties that we saw above. Don't overcomplicate it, right? What do we know from above? This is equal to that, is equal to that, is equal to that. And this segment is equal to this segment, which is equal to this segment, which is equal to that segment, right? That's what we just said. And that's all we're going to use. That's all we're going to use. So if AB is 16, then AF is 8 and FB is 8. And if A to B is 16, then C to D is 16. And therefore CE is 8 and ED is 8. If GD is 48, then GC is 48. And if these two things are 48, then the entire thing is 96. And if these are 48, then these are 48. BH is 48 and AH is 48. The chords are equal distance from the center. So if OF is 5, then EO is 5. And they are perpendicular bisectors, so therefore that is a right angle. They're just reflections of one another. You can look at it that way, right? You could draw a line right down the middle of this, and everything is going to match up. All right. Only one other question, right? Only one other question. This isn't too lengthy at all. I hope you appreciate that. It's just a reflection, right? You can draw a line right down the middle. Everything's the same about these guys. So EO and OF are perpendicular bisectors. If EO is 3x plus 5, OF and OF is x plus 19. The typing was kind of weird there. Well, what do we know about EO and OF? They're equal, right? That's the whole point, that this chord is the same distance from the center as this chord is from the center, right? The whole point is that these two guys are the same length. So EO is 3x plus 5 and OF is x plus 19, but in the end, they're equal. So solve for x. X equals 7. And if x equals 7, if that's true, plug it in to find the actual distance. If you plug it in, 3 times 7 plus 5, that's 26. And if you plug it in here, you get 19 plus 7, which is 26. So both OF and EO are 26. What are AB and ED, you ask? Well, this is an equation for CD. If you can find CD, that's the exact same length as AB. So let's plug in X for that. And you get 10. So if CD is 10, then AB is 10. And what's half of 10? 5. Which is why ED is 5, and EC would be 5, and AF would be 5, and FB would be 5. And that, ladies and gentlemen, is the gist. That's it. Just remember, it's one giant reflection. I didn't ask a question, but here's the question, a fun question on the screen right now. Boop. Thanks for watching. I'll see you in class.